All right, so recording has started. Hey everyone, I'm Dr. Sergey Sarkisov, and we're having our day 16, I believe, of the class of business math or finite math, as I call it. And we're studying the topic of exponents and logarithms. So let's go ahead and actually continue where we left off. We didn't do much on logarithms, but we did exponents quite a bit on Wednesday of last week. So let's go ahead and look back, review a little bit of logarithms. If y'all remember before that, what did we do? That simplex method. Remember the optimization, those equations, the three equations and all that. It was very difficult, right? So I would say this is not more difficult. This is like maybe lighter on the chat, like how difficult conceptually it is the material. But it's very important. I would say probably more so than not. So let me say right here, you can see that, yeah. Exponents. This not absorb. All right, let's do something else. So exponents. And we'll do exponents and logarithms, but let's do exponents first. Or an exponential functions. Okay? So let me show you what this is. First of all, there's a property. Let's do properties. So property E0, as I call it. When I tell you a number, it's called base actually. Like base A. Base A. To the power. Power is the exponent. Let me do a negative m over n, just so you understand, like a clear picture of what all this can do. So if you have a to the negative m over n, what is, and we've done this again on last week, right? But so what does the negative do? Anyone remember? And y'all feel free to talk, feel free to like answer the questions. It's actually going to help the rest of the people. So negative means you reciprocate, flip it, right? Remember that, everyone? So what do? 1 over. Now, if it didn't have a negative, you don't do 1 over. You don't do that. But like if you have a negative 1 over, then what? Well, a to the what's the n doing? Anybody at the end of the bottom? Like 1/2, 1/3. And 1/2 is square root. 1/3 is cube root. What is n at the bottom? The what root? Nth root. You know, if we don't write anything up as a 2 there, square root. Or sometimes we do like square root of 9. We don't put the little 2 there. But then it's square root. Otherwise, it's cube root 4 through. And what about the m? We take it all to the m power. Okay. Make sense? That's kind of the definition. So if it doesn't make sense, you may like, why is it the case? Well, it's just because it's defined to be one of the ways it's defined. Powers are defined. Powers, exponents. So let me show you examples of this. Let's do some examples. So, for example, let's do something kind of lightish. Okay, 2 to the power of 3/2. Let's do 1 second. Let's do 2 to the power. Let's do 4 to the power of 3/2. That's what would that be? What does 2 to the bottom do? First of all, square root, right? Yeah. So square root of 4. We'll just write it. We know what that is. Everyone knows square root of 4. What is square root of 4? 2. So okay, what is this? And then what? Cube it. Get it? That's what it means. What's the square root of 4 again? 2, and so what is it? 2 cubed? What's 2 cubed? Well, let's say you don't know. You do 2 times 2 times 2. What is that going to be? Anybody know? 2 times 2 is 4 times 2 is? 2 times 2 is 4 times 2 is what? 8, right? No, so yeah, I'll say it. Especially a few people, it'll be kind of easier for them to see actually when I have class and stuff. So anyway. Now what happens is, let me show you a calculator, because sometimes people confuse this like with, is it doable on a calculator or not? Like in a real life setting, let's say you don't even think, you can. Let me actually show you. I'll get a calculator, I'll show you what's going on. But try these buttons, okay? You click 4, right? You start with 4. And then there's a button X to the Y, okay? In the recording you'll see that, so let me show you in a second. See where that button is. There's a button right here. See where's it? X to the Y. You'll see that button right there? Right there. So X to the Y button, right? That's kind of silly, but all right. So anyway, so there's X to the Y button. Try it on a calculator. What do? You push 4. See that? That X to the Y button. You may have A to the B. You may have a hat. Okay? I click that, and then what's 3/2? 3/2, so 1.5. You do parentheses 3 divided by 2 plus 4. You do 1.5. 1.5. Equal sign. What do you think I'm going to get? 8. Is it 8? Makes sense? It's not random, okay? Now let me show you another example with a calculator. So y'all try this. Y'all do this one. Let's say things are tripling or even let's say doubling. Let's say like remember that infectious diseases. Let's say they're growing exponentially, double. So maybe one person gets another person sick every day. So there are 2 people sick next day, right? Then each of those people get a person sick. So then it's 4 people because they're sick, and then 2 people are sick from them. Then from those 4, there are 4 more. 8 people are sick. 16 people are sick, right? So let's say you're like, you know what? Let's say there are 30 days this is going on. 1 person, 2 people, 4. So 30 days. That means if you do 2 to the 30th power, what is that? Let's say 30 days, a month. This disease, people are getting sick. Everyone's getting each other sick. Everyone's sick. So you do 2 to the 30th power to calculate, right? You can't really do this in hand. And what do we get? I think it's about 1 billion, right? What is it? Somebody tell me. 2 to the 30th. What is it? 1? 745? 1? Okay. 824. So you see, 1 billion, blah, blah, blah people, that's like an eighth, more than an eighth of the world population, right? You just do 3 more days and everyone's dead or everyone's sick. That is an example, right? When we're talking about COVID and how it's spread. If it happened, that would be called R factor is 2. And we had R factor, like even newspapers, like not necessarily math anything, but like I think like New York Times. I think it had like, oh, the R factor right now is, I remember it had that like during the COVID time, 2020, 2021, people talked about that. Nobody even knew what it was. It was that number. I think the R factor was like 1 point something, because I mean 2 would be everyone dead already, right? It was like not that bad, but it still was bad. And it was changing over time. But anyway, that's exponential growth is very fast, basically, right? Like what is 30 squared? That we know we don't need a calculator. What is that? What's 30 times 30? 900, right, everyone? So you understand everyone what's different, what's bigger? The 1 billion numbers. You see, exponential is much bigger than powers. Even that. So just an example there. All right, so no more needed. Well, actually, let me tell you a few other things. It's really cool. If you're doing like later, we'll do financial math. All right. So let's talk about this. It's a really cool example. Remember the cost of a house? How we did that a little bit? Now, let me show you. You don't remember. So just one thing we're going to talk about. Let me talk about the cost of the house. So for example, let's say you have a house. Let's say like, okay, watch this. So cost, house price. Let's say it's $300,000. Let's say like a 2-bedroom in an okay area in Houston. It's realistic. Okay, let's say APR. You know what an APR is? Annual percent interest rate. APR. You know that, like interest, APR. So every year, let's say APR. Let's just pretend it's 5%. That's a realistic, actually not a bad number. It can be worse these days. You know what that means? Let's say the bank, whoever's giving you the loan to buy the house, like, you know, because you obviously usually don't have right away $300,000 to give. Even if you do, that's kind of a way, like, it's kind of unwise to do that. Because why? Because it's a lot of money to just throw away. Inflation, maybe things later, you know, that won't be as, you're still paying the same fixed rate, let's say, but maybe later that money will not be as valuable as it is now, right? So there's an advantage to waiting a little bit here and there, not to just pay it off right away. If you have a lot of, like if you're a millionaire, like multimillionaire, maybe this is not a big sum. You want to just pay it off, so you don't actually have to pay more over time, right? But if you, like this is a big deal for you, like if you don't have or whatever, you're probably going to pay over like some years. Okay? So let's say APR rate is 5%. That means what? Let me give an example. Let's say my friend asked me, hey Sergey, Dr. Sergey, whatever, can you give me some money? I'm like, look, I can't always borrow, I can't let everyone just borrow money from me, especially if like it's not a close friend, right? Like my mom and dad, obviously, like you can just have, whatever you want, you ask me. But like, so I'm gonna say, you know what? Yeah, but if you want to borrow, because I need this money too. But if you really need it, I'll give you my $100. But give me back 105. I mean, like, come on, I need the money right now, but I know you need it more. But pay me back 105. You understand this is not a joke. Like, I want extra a little bit for it. Makes sense? Because I don't have it, so I'm losing the fact that I can't do anything right now with it. He actually, or she, if they have $100, they can actually do something with it, whatever it's worth. But they have to give me 105 back, like 5%. That'll be like that, right? So let's say a bank gives you a loan to use for buying the house, $300,000. And you have a good credit score, meaning you can maybe choose your options of how many years you're going to do this of paying it back. So let's do two examples. You pay off, and so pay over loan, it's called the term of the loan of, let's do 30 years. That's usually the longest they can let you do it in. Or maybe you do 5 years. Let's do, which one's 5 years? Okay, so like in green. Or pay over course of 5 years. Makes sense? We'll do 2 examples. So a question that we have is the total cost that we'll end up paying, total payment that we'll do over the years. Let's see how much it is. Are we going to pay $300,000? We're going to pay actually probably more, right? Because we're going to keep on borrowing money, right? We're going to pay a lot more. So what's the total payment after paying off the house? Okay. And what's the monthly, right? We care about like monthly. Usually that's what we care about. How much month we're paying every month, right? Monthly payment. So let's see what happens. So, but monthly payment, we're gonna have we're obviously 30 years we're gonna have more monthly payments. But hopefully, if you do 30 years, it's gonna be less of a monthly payment. So you're wondering, like, I'm gonna ask you, what are you gonna do, 30 or 5 years? Let's see. Let's see what we're gonna do. Well, let's do the red one, 30 years. All right. What you do, you gotta get your calculators ready. That's where I was remember that X and Y button. This is where you can't do that without that button. All right. So you'll see this in our unit. So coming up right after the exam 3, we're gonna do the financial math actually, right? Like for like 2-3 weeks before the final exam. And we're gonna be doing this again. So it's good. We've got a preparation for it. So watch this. Let's do the total payment on the red one, right? So 30 years. So payment, total cost, payment, let's say cost, total, equals 300,000, all right, 300,000. Then what do you do with 300,000? You multiply, you know what 5% means? 1.05, right? The whole thing you're paying 1 and 1.05. So it's going to charge you over every year like this much more. To the what power? 30th power. And what number, somebody do this on a calculator, tell me what you get. 1.05 to the 30th power, and then multiply that by, I would do that first, and then multiply by 300,000. Is it 300,000 or is it more? It's more. How much more is it? We're going to pay a whole bunch. Yeah. So what I tell people, it's kind of interesting, but let's say your house is paid off. Like your family somehow paid off the house, and you're like, well, we're not millionaires. Most people aren't. But if you have a house paid off, you kind of found somehow $1 million somewhere here and there to pay it off. And believe it or not, people like somehow over time things like accumulate, month, where you actually somehow like if you have a house paid off, probably something you do, like a family, you live and you're like, well, mom and dad finally paid off the house. Maybe not. Right? Many people don't. Right? They always just pay it off and pay off and pay off. But if you live somewhere for 30 years. You probably have it like finally paid off, unless you're in big debt or something. Anyway, so what is that? Was it 1 million something? So wow, right? So it's going to be actually not. You're not going to pay 30,000. You're going to pay if you're doing this 30 years. What is it? 1? Like this? 1,296,000. 582 and what? How much cents? 71 cents. Okay, you understand, like that's why some people don't want to, I wouldn't want to do 30 years if I know I'm going to end up paying $1 million. I mean, that's not $1 million. That's like $1 million more to the 300,000, right? That's $1,300,000 right there. Y'all see that? Yeah, it's really what you're going to end up paying if you do this. Again, 5% is actually a realistic rate these days. It's actually not that bad. People are like, oh, let me refinance for 5%. You may find 7. That would be like a lot more. What's the monthly payment? Monthly payment. So what do? You take that number, total cost, that number right there, the same one, and you divide by what? How many months are there in 30 years? Anybody know? How many months? 12 months a year, 30 years. 360, right? 360 months. what do you get? Somebody do, what is that? How much is the payment? 3,600, 601. How many cents? 639? So 62, right? Is that okay around? Everyone get it? Okay, that's a realistic payment. People make that these days. Make sense? Like people pay that. I mean, at least you're paying something out that it's kind of yours, besides the property taxes, all that, right? You get it? So it's like, I mean, there's apartment 3,000. That's like the same thing. Or you can live in a house. You kind of have more freedom, whatever. You're paying that much, and it's also you're paying off something that's yours versus just giving it to somebody, without anything in return. And also, there's taxes and a little relief here and there, government. If you're good with money, I'm not saying I am, but there are like a person who studied business. They're able to figure out ways to figure out what's the better doing 30 years, or maybe I'll do like this, but I'm doing other investment, and the money can be brought by this. So that's why, if you know money well, if you know math well, you can survive much more in this country than if you don't. Make sense? Like it's a really a game of numbers. For example, let's do the green one. Green one. Total. How much are you going to pay here? Total. Hopefully it's not $1 million. You have to do it in 5 years. So total payment equals, now we do in the 5 years, not the 30 years. So we have to do it sooner. That's going to be harder. But maybe it's not that much different, but we're going to pay up a lot less in the long run. Let me show you when you would choose this option. So 1.05 to the what power, everyone? 5 years to the 5th power. What is that about? What is that? So 384? 82,000, 884. And how many cents? 36. Y'all see, that's like, would you rather do that? I mean, if somebody asks, hey, you want to pay $1,300,000 or you want to pay, I would honestly really hope to do that, especially if it's like a burden on my family. Let's say I'm not the one really paying, whatever. Or like, let's say, but see, here's the thing. So 5 years, I have to pay it off. 30 years, I can be like, you know what? I don't even know if I'm going to be able to live here. Maybe I'm just going to give it up to somebody, and they'll be paying for the rest. So you see, this is more like a selfish thing to do. I'll pay less monthly, but I'll do it 30 years. I may never pay it off. Basically, make sense? Like imagine something happens, maybe I pass away. Hopefully not, right? And so people are paying it off. I just did this a month. I didn't think about that. Actually, this is how much somebody has to continue to pay it off. Now, let's just do the monthly payment. Now, this should be more. Why? Because we're dividing by not 360, by how many? How many months are in 5 years? 60, right? So you do total over 60. I just want to show you this cool example here. Over 60 months, all right? And what is that? I'm guaranteeing it's more than this because you're doing it faster, even though this is much less. What is that about? 6,381. And how many cents? 40, okay? Okay, so now you see why people would do 30 years. Some people don't make, it's hard to make that. Like, this is like cash. Like, it's not like even like without the tax. This is after the taxes and all that. That's a lot of money to be made. Like, look, think about it. If somebody's making this, okay, so 12 months, right? What's this? This is just like, let's say you just make just that. Like, how much? So what's this times 12? About 76,000, right? To get $76,000 cash, you have to make 6 figures. In U.S., because it's like if you make 100,000, for example, it's actually kind of like 60 cash. It's not going to be any more than that. So already, if you're a 6-figure, low, you can't pay this house. So you're going to do them like that. But the problem is you're going to end up paying $1 million ultimately. Get it? That's rough. So it's like you have no other option but to give them $1 million extra. That's why people do what they do. Now there's an advantage to each of these and a disadvantage to each of these, right? What do you think somebody that has multiple millions, like many millions of dollars, what are they probably going to do? They're just probably going to pay this right away. That way it's even better than paying that, than that. But who has not everyone in America has that much right away. Especially if you do, it may be still very significant to you, right? Like if you want to do something like buy a car, go vacation, whatever, if you do that, you can't do anything else. I'm talking about like somebody who even has that. Like, I don't know many people who have that. I don't know many people have. Like maybe a doctor who's done it for many years. Say that, like, and, you know, like that's not easy because you're still paying a bunch of stuff. So anyway, that's just sharing with you a little bit about the exponents and how you do those buttons. What were you doing basically? You were doing, how did you do this? This is kind of tricky. This one right here. You do 1.05, that pad or X to the Y button, and push 30, and you get the number times that. It's really cool. It's like when we did this one here. Now, let's continue with exponents. So, you know, I just gave you, I've given us what? I've given us just the property E0, just what the definition is, right? And let's even mess around a little bit with it. Let me give you another number. So let's make sure you understand this. All right. For example, what if you do this? Let's say I have, let's do 9 to the negative 3 halves. What if I do that? Anybody know what that would be? So what is, and this is like not calculated. What do you do? What's the negative do? Reciprocate, flip, right? Now. So 1 over 9. Let's just copy kind of what this means. What does the n do? What's the n? What's m? The 2, the square root, right? So square root of 9. We know what that is. What is it? 3. And what is it? To the what power? Third, right? So it's 1 over 3 to the third. You know what that means? 3, 3, 3. What is that? 1 over? What's 3 times 3 times 3? Anybody know? 9 times 3 is 27. So it's 1 over 27. That's how you do powers with numbers. Okay, that's property E0. That's property, we've done this already. I know it's like it was kind of fast in the class on Wednesday last week. Okay? So let me talk about properties E1 and E2. E1, what that is when we multiply, so you have like, let's say, a base to a power times the same base to another power, exponent. What happens? Do you remember? You add the m and the n. Yeah, so it's like this. A to the m plus n. Okay? This is basically, let me show you an example. Let's actually property A. And if I do B, guess what? If I do A to the m and I divide by A to the n, you know what that's going to be? Subtract, exactly. So A to the what? M minus n. Okay? But let me show you again. It's like kind of like, really? Why is that? Like, I'm going to show you an example. So, for example, let's do 2 cubed to the 4th power. I mean, times 2 to the 4th power. We don't even need parentheses, but okay. So what's 2 cubed? Well, just definition, 2, 2, 2, right? And we know it's 8, but let's not even worry with that. So 2, 2, 2. What about 2 to the 4th? Who knows what that is? 4 times 2, 2, 2, 2, right? What is that? How many 2's do y'all see the total there? 7. 3 plus 4. Get it? Because you have 3 of them there and 4 of them there and it's plus. So it's equal to 2 to the 7, which is exactly 2 to the 3 plus 4. Cool, right? What about division? All right, well, let's divide. 2 to the 3rd, divide by 2 to the 4th. You all see how it's actually 1/2 ultimately? Because it's 3 of them, watch this. It's 3 of them cancel. Because it's 2, 2, 2, 2. So you subtract basically 3 and another 1. What's 3 minus 4? Negative 1? 1/2 is negative 1, isn't it? See 1/2? So it's 2 to the negative 1 power, which is 2 to the 3 minus 4. Do you see how to subtract now? Because you have less, like you take away, you cancel 2's now instead of actually like multiplying, you actually cancel it. You go to the bottom, some minus. And then what happens is there's one more property E2. What's property E2 about? Property E2 is the last one of these. It's when you have a power to a power. For example, so A to the m, and I do 2 to the n power. Anybody remember what that is? You multiply m and n, yeah. So A to the what? M, n. M times n. And that would be, let's do the same 2 to the 3rd, 2 to the 4th. What if I did this? 2 cubed to the 4th power. Now you're telling me it's 3 times 4 is 12, right? 2 to the 12th? Well, why? Let me show you what this means. 2 cubed to the 4th means 2 cubed times 2 cubed 4 times, right? That's what it means to the 4th power. And what's 2, 2? That's a 2, 2, 2, 2, 2, 2, 2, 2, 2. How many 2's is that total? 12 2's, right? 2, 2, 2, 2. So if I write it out, 2, 2, 2, 2, 2, 2, almost like a song. 2, 2, 2, 2, and then 2, and then we count them up. We have 12, and that was because it's 3 times 4. This 4 of multiplies of, remember, word problem language? So that's why we get 2 to the 12, which is exactly the 3 times the 4. See that? So we can multiply 3 times the 4 and get that. So 3 times the 4. So that's how these work, okay? And so now what am I doing with this? Let me show you an equation. An equation that can be done. So example, let's do exponential equation, it's called. Okay? Let me show you one like this. So let's say I have, okay, let's say I have 1 over 8 times 4 to the 3x minus 1, okay, equals 2, right? The square root of 2 to the what power? Let's do something like this. 4x plus 8. Okay. Let's say you have that, and even like something kind of like this, divided by 2 to the 5x minus 3. So let's say I have this big mess. Y'all see that? A whole bunch of stuff going on, right? What's the kind of the key number that we're worried about? That's a 2 to that power is divided by all this stuff right there. So what is that number that we're actually really manipulating? Y'all see? Like what's the kind of the ground, the core number? Made of, everything's made of what? 2, right? Y'all see that 2, everything, 2 powers of 2. So what I would do on the side is I'd say, you know what? Let's do solution in red. Red's going to be hard to erase, I think, but not do red. I see red not being erased now. I'll do red. All right. So here goes. What's 1/8? That's what? 2 to the what power? Let's just do it here. 2 to the not third, but negative 3. Yeah, exactly. So not 1/3 anything, negative 3. Because 1/3 would be the cube root, right? 1/8, 2 to the negative third. Y'all get that? 1 over and 2 cubed. Huh? 2 cubed, 2 to 2. Nice. Okay. What about 4? Yeah, 4 is 2 squared. What about the square root of 2? Who knows what number of powers that? 2 to the what? 1/2, right? And the other one is just a 2. Okay, now, let's check it out. So you have 2 to the negative 3, right? Times 2 to the second, right? That's 4. That's 4. 2 squared times to the 3x minus 1. All right, let's see what we can do that. Equals what? Square root of 2? That's 2 to the 1/2. To the what? That power, 4x plus 8. And then what is this at the bottom? 2 to the what? 5x minus 3. So let's simplify this the best we can. You see how, let's keep the negative 3 by itself for now. 2 to the negative 3. And what is this? You remember how we multiply those? What's 2 times all this stuff? 2 to the what? What's 2 times 3x minus 1? Exactly. So that's what that ends up to be. Right, so far? What about on the right side? Let's see what happens. 2 to the, what's a half of 4x plus 8? 2x plus 4, okay, that's nice. So 2x plus 4. And all over what? 2 to the what? 5x minus 3? Okay. Now, do you know how we would do here? If you multiply, you add, right? So what happens? It's 2 to the what? What's a 6x minus 3 and minus 2? Add those together. Powers. 6x minus what? What's minus 3 and then minus 2? So you've added 6x minus 3 and minus 2. 6x minus 5, right? Everyone okay with that? Okay. So 6x minus 5 is the total power here on the left. And on the right, what happens on the right? You have 2x plus 4 minus, right? Because you subtract. So 2 to the what? What's 2x minus 5x? Negative 3x, yeah. And what's 4 minus the negative 3? Positive 7, right? 4 minus, so plus is 7. And remember, what we did here is that minus that. that minus a negative 3x plus 7, right? So now when we have a 2 to the power is 2 to the power, what happens? The powers are the same, right? Like think about it. If I do 2 squared, that's 4. 4 is 2 squared. It's not 2 anything else. 2 squared is 2 squared, right? So I need to match these up. I need to equal them. We now have a linear equation coming out. 6x minus 5. You have to solve just this. We know how to do this. You know how to do this, everyone? This is a long time ago we did this. It's like before this class we did, right? What do? Add 3x to both sides. What happens? Y'all see 9x equals what? 7 plus 5 is what? 12. So what's x equal to? What's 12 over 9? 12 divided by 9 is equal to? Oh, cool. Without a calculator, 4/3, right? Yeah. Right, cancel the 3's, 4/3, yeah. That's how you do that. Like, so that's how you solve an exponential equation. You try to make it easier, and obviously a lot of steps here. I give you a tough one, where everything's involved, all these properties. Y'all get it? That's how you do that. All right. So now, here's that's the exponential equation stuff. Let's now look at that for a moment. I'm going to erase the board, and we're going to go to logarithms for the second part of class. Do logarithms a little bit. I won't do everything about it, but we'll do some, and then we'll call it class after that. So about half class. So you see all that stuff. I'm going to erase it. Send me the notes. Actually, it's going to be in the recording. Notes, maybe I'll upload it too, but I don't think I will. So I'll take a picture in case. Yeah, you can take pictures or take notes if you feel free to do that. In case y'all want to share them, right? So anyway, that's that. Here goes with. Y'all understand exponents a little bit more now? Let me show you. So we're going to do logarithms. Logarithms are actually kind of the same idea, just go backwards. But it looks kind of weird if you've never seen it before. It's a little tougher than the next one with so many people, but we'll see. So I'm going to erase this. Let's take a look at logarithms. So we'll stop. So, logarithms are very common. So like exponential is like growth, modeling, like population changes, exponentiation, like there's exponential growth, exponential decay. Logarithms are very similar. It's like it's like inverse actually of exponents. Okay, but for example, like what we're doing now, what you like in medical field, where is this possible to possibly use? Like for example, let's say take Tylenol or something. So any substance, any medicine, anything, right? You take anything it has a half-life. It really does. Like if you study half-life of, I can look it up if you want right now and let me know. But I don't know, but let's pretend you take 1,000 milligrams Tylenol. I don't know the half-life, but just pretend it's an hour. It's more, right? But let's pretend it's an hour. But okay, so in an hour, I think it's more. Okay? In an hour, what are you gonna have left? Half-life, half is gone. So from 1,000 milligrams, how many do we have left now? 500, right? In 2 hours, how much are you gonna have? 250. So it's a lot less. We don't have much in the body left anymore, right? In another hour, for 3 hours, you have 125. 62.5, right? So you understand, 62.5 is much less than 1,000. So after some hours, you have basically nothing left in your system. Also, like the excretion, the absorption, all this stuff, right? And so that's why. But notice this: if you take even a lot of hours go by, you still have a little bit left, right? So you understand, if you took some substance, let's say, and then you go many days forward, you still have a little bit left. Is it detectable? You know how those athletes get drug tests, right? You know what happens? If it's recently they did something, they're gonna get caught. It's still there in a measurable level. But of course, at a half-life, if you go if it goes a month without, it's undetectable at that point. You can still have a little bit of something left, right? The person took versus not. You understand everyone? So that's how that works. That's also studied, right? You want to know how medicine affects and how long it will last, and how many doses you should take a day, with food, without. Maybe that would increase the half-time or half-life or whatever. So, all right. So that's the idea there. We definitely did in financial, right? That's exponents. Talking about money and time and money and all that. So a lot of things are exponential and logarithmic. Logarithmic, one thing people use logarithms for is, sound, right? As I'm talking to you. There's a thing called decibels. Okay, it's a logarithm of basically the kind of the amplitude of sound. So a decibel is units of sound. So it kind of goes to the log base 10 scale. I haven't really taught you logarithms, but I'll tell you this. The numbers are so big that we start talking about order of magnitude. Okay, so instead of me saying 10, one person, oh, this is like about 10 people, this is about 100 people, it's about 1,000 people, about 10,000. You know how we sometimes think that way, like order of magnitude? Like, how many people here? About 10. It's not 1, it's not 100, right? It's about like 10. Like 10 of us, it's actually like 8 of us, right? But makes sense? You know, we sometimes say how many pennies in a jar, and you're like, well, I don't know if it's 1,000 or 10,000. Yeah, I mean, you can tell, hopefully you can tell at least that. Right? You may not know if it's like 1,200 or 800 or whatever, but you know it's about 1,000. It's not like a million pennies. It's not a million pennies are not there, right? People in the world, billion, right? 8 billion, about 10 billion, right? Like, so instead of me calling it 1, 10, 100, 1,000, 10,000, you would say, oh, 10 to the 0 is 1. 10 to the 1 is 10. 10 to the 2 is 100. 10 to, make sense? So you talk about now 0, 1, 2, 3, 4, 5, instead of talking about it as like a big numbers. That's the idea. So decibels, you do that because for sound, you can hear, in decibels it's easier to understand, like when is something too loud for you to basically lose your hearing. You know those music concerts? Sometimes they go over that threshold. And that's when you that's why if you don't have those things, what are they called, earplugs, you can lose your hearing to a degree, or if not at all, completely. Y'all been to a music concert before? Pretty sure y'all have more than I have. So, yeah, I mean, it depends, right? On some of those are really loud, so you have to have those earplugs. I can hear me, so probably still haven't gotten too bad with that. So anyway, similar with light, like it's a little different, but like if you look at light that enters your eyelid, there's also that power, and then it can burn, like, you know, a laser beam, it's so concentrated in one spot that it burns. It can burn your, make you go blind. All right, so let's go ahead and look at this. A logarithm. Yeah, let me show you what this is. What is log? L-O-G, logarithm. You have buttons on a calculator to say this. Logarithm. Logarithms, logarithm. What is that? Well, let me tell you property L0. You know how I did E0? Let me give you a definition. If you ever see log A, B equals C, anybody ever see that? All it's saying, everyone, is just saying it's by definition, okay? It means, like, let's say you don't like log. I'm like, it's so weird. What is that? You can also write it as A to the C power is equal to B. These are identical. The same thing, by definition, that's what log is. Okay, so why would we do that? Sometimes this is more helpful to write than that, that's all. That's fine. Let me show you examples. So let me ask you this. What's 3, I'll go log on the left. What's 3 squared? And we know it, well, what is that? Everyone get it's 9? 3 squared is 9? You know that, right? So this is kind of easy, like why are we doing that? We already know that. But let me show you. What if I did this? Log, let's write it, help me write it like the same way. So log what? What's the A here? Match it up. And then what's the B here? Is it 2 or is it 9? A to the C is B. So what's B? 9, right? So you do log 3, 9 equals 2. So these are right down. Y'all see that? So what if I asked you, let me show you a little different. Log 2, 8 equals. What do you do there? What number is equal to? So if you don't know, what's the thing? You put like an X or whatever. Let's do a circle. Mystery circle. Mystery box, whatever, right? Let's do it on the right. What is it? What is that equivalent to? 2 to the circle is equal to 8, right? 2 to the missing number is equal to 8. 2 to what number is equal to 8, everyone? You should know that. 8 is made of how many 2's? 2 times 2 times 2 is how many 2's? So log 2a is 3. Make sense? Because you always look at this, look at this. When you see this, this means this to that power is this number. Okay? That's what it means. So so anyway, thanks. So you see that? Let me try another example. Let's see, usually you don't get that. You just go from, you just have to go to this. What if I did this a little tougher? Log 9, let's see, like actually log 25, 5. What in the world is that? I'm going to verbally more than say than not. What is log 25, 5 of 5? So you ask yourself the question, 25 to the what power is just a 5? How would you get from 25 to a 5? Just think about it. You do what? No, not from 5 to 25, but from 25 to 5. Do the what? Something root. Square root, right? Yeah. What is the square root? What power is the square root? I told you 1 over 2, right? 1/2. The answer is 1/2. Because, and we're okay, with 25 to the 1/2 is 5. 25 to the 1/2 is 5. You see how you have to know exponents to do this. Let me show you an example. Let's practice a little bit with this logarithm number stuff, right? Not log. Let's try, let's do this. Let's show you something cool. Let's say I have 4, and I do 1 over 8. What do you do with that? So think about how do you go from 4 to 1 over 8? Now let's say you don't see that. Okay? Some people don't see that, right? It's not that easy. What do you do when you, in algebra, what do you do when you don't see something? You call it what? Like x? Like, right? Like unknown? Like I don't know? So I'm like, all right, no, I don't know what this is. I'll let x. And what happens? Then you try to solve for x, right? So let's use the definition. Help me out. What is it? 4 to the what power? To the x power equals what? 1/8, right? Okay. And then you do, remember what we were doing there, that equation, or there, the top equation? This is easier than that one. What is 4? 2 squared, right? So it's a 2 to the 2x, right? If you go a little further, 2 to that, 2 squared to the x, you multiply 2x, 2 times x. And what is 1/8? 2 to the what? Not 3, but negative 3, because it's 1 over, right? So if 2x is equal to negative 3, x is equal to negative 3/2. Do 2x is equal to negative 3. Okay, so would it make sense if I told you, hey, you know what, we're going from 4 to 1/8 to get there? Look at this. We square rooted, you see that 2? Square rooted. What's square root of 4? Now 1 over, because it's negative, and then you cube it, 1 over 8 of this. So you see how you could feel this out, this number, it's a little tougher. That's how logarithms work. Okay, so let me show you properties of logarithms. Let's go property L1. Okay. So property L1, if you're adding two logarithms, log a x plus log a y. Any ideas what happens? It's called property A, by the way. You know we were multiplying the numbers that we add the exponents? Do you see how this c is actually the exponent, right? So for adding the exponents, you're multiplying the numbers. It's going backwards, think backwards, right? So remember this property here. It's a full property. At log a, x times y. Okay? So if you do log a plus log, if you do log x plus log y, it's log xy. Everyone? You want to do one logarithm written? Let's do that. Yeah? Let's do property b. That's when I subtract. What happens? Look. Log a x minus log a y is equal to what? What do you think that's going to be? If I'm subtracting, remember how I divide the numbers? And that subtracts the powers. So log, what would you do? X over y. Okay. Cool, right? That's another property. And you can actually see how you're actually adding a negative. So it's really, that's why it's going down there. This is a -1 power there. But we haven't seen this other property, so we have to see one more property. This is the only other one I'm going to tell you. It's called L2. We're going to call it L2 property, second one for logarithms. So we have the 0 definition, basically definition. And then we have L1 and L2. So L1, that's going to have a number, a constant, some number, times a logarithm of some number x. You see this constant k? You can make it a power. Okay? So this constant k, you can make it a power. So you can do log a x to the k. Y'all see that? It's going to be the same thing. All right. So let me show you how we mess around, play around with these logarithms. Let's do examples. Okay, watch this. So example, that was example, sir. That was the example. This one, I'm going to tell you this. We're going to put together a logarithm into one. Okay? Put together, or compose. No, put together, compose into one. Okay. Logarithm. No, it's not a logarithm. Okay. Here's an example. Watch this. Let's say we do 2 logarithm 7x minus 5 logarithm 7t. And then let's do plus 1/3 logarithm 7. Let's do like y. Or like some letter, like what is it? Let's do, I'll just do y because it's easy to see. Okay. What is that if you put it together? Make your 1, right? How would you do that? Use these properties. Get it? Let's try that. So let me show you what I mean by that. So you have equals to, let me ask you property L2 first. What's another way to write this? Log, what is it? Log, what is it to? It goes up there, right? Is that okay? So log 2 what? Anyone see it? Log 2, I'm sorry, log 7, and what does it 2 do? So x what? X squared, right? Yeah, x to the second power. Anyone see that's the same thing? That's property what? L2, right? Let's just do L2 everywhere. What about this one? Minus 5 what? Oh, 5, what do we do with 5? We bring it up there. So minus log 7 what? 2 to the power 5, yeah. Let's see that. Get it? The 5 comes here. Why can we do that? Property L2. What else? Plus, what did we do here? Log 7. Y to the what power? 1/3. Now, everyone knows that's the cube root, actually, right? That's cube root, right? So, cube root. All right. So, we'll do, finally, if I subtract and if I add, what happens? Subtracting, I divide, right? I see that? And what happens if I add? I multiply. So, on the top, the multiply, the numerator is if I'm adding. Denominator, if I divide, right? If I subtract. So, look. Log 7. Okay. We have x squared. Do you see the plus? So you see that y, the cube root of y, or is it on the top? Y'all see that? And what about dividing? Bring a minus, so divided by what? T to the what power? T to the 5th power. That's how you do that. This is our final one. You'll see how that weird one's made of these little ones. That's all you would do. Get it? I know it's nice to take a few examples, but you see what's going on? Log 7x squared, that's just, I'm sorry, 2 log 7, that's just an x squared on the top there, the log. What about minus 5? That's at the bottom, t to the 5th. Oh, that's a cube root of y, but on the top is this plus. Make sense? That's how you would do that. So let's do one more example where I'm going to put together the logs. Sorry, not put together, decompose the logs. So, decomposing, let's decompose. Or break apart, separate them. So decompose. into logarithms. Smaller ones, right? Decompose logarithms into smaller ones. Okay? So let's try this one. Let me give you a little trickier one. So log 3. Okay. Then we have, let's do a to the 11. It's a weird number, 11. Okay. The square root of b. Okay. Let's do t to the 4th. Okay. All over 9. Let's do x to the power of 3. Okay? That's a whole bunch of weird stuff. What do I do with that? It's not impossible. You see, logarithm of this whole mess. How do you make it look like a separation of little logs, of just individual logarithms into individual logarithms? How do you do that? So what we do is, let's go kind of straight to the answer almost. Like, let's do 2 steps, not like 10. Right? So watch. This right here. This what? You see this right here on the top? You're adding. If you're doing multiplying, you're adding or subtracting. This you're adding, and this you are subtracting. What? So what happens? You have anybody okay with log 3, a to the 11th? Right? Everyone? And then what happens? Make it 11 actually. Look 11. So 11. Then what? Do I do with the square root of b? Do I do add or subtract? Add. It's on the top. Multiply, right? It's multiply, it's divide. So plus a log 3. Let's do all the addition first. What is that? That's b to the 1/2, isn't it? You know that? It's the 1/2 power. And what is t to the 4th? That's actually plus log, what is it? 3t to the 4th, right? And then what do you do? Then we have to do minus. 9 and x cubed, right? So minus what? Let's do right here. Minus log 3, 9. And we actually, anybody know what that number is? What's the number? And then watch this. Minus a log 3 x cubed, right? You still have to keep the same base though. Like 3, 3, 3, 3, it's what it was. It's 3. Okay, so let's finalize this. What is it, everyone? Let's property L2. Let's finish this off. What is this? Yeah, and what happens? 11, what? Yeah, like that. And then what? Plus a half of these, right? Log 3b. And then what? Yeah, 4 log 3t. Right? And then what? Minus, 3 to the what power is 9? 3 to the, this is actually 9 is 3 squared, isn't it? You just what? 2. You see that? Just a 2, right? 3, that's kind of tricky. 3 to the what is, that's just a number. And what is this? Minus what? What's the finalize? Y'all tell me out. 3 log what? Base 3 of x. That's how you do that. You see that? It's 11 log 3a plus 1/2 log 3b plus 4 log 3t minus a 2 and minus 3 log 3x. Get it how you decompose, you separate the logs into logarithms. So you do that. All right. And then, see the remaining time we have. There's some time. What I'm going to do now is I'm going to show you a logarithmic equation. You know how to do exponential equation? Let's do one logarithmic equation. If we don't have time for much more, we'll call it class soon enough. But let's put a lot of effort into this one logarithmic equation. So here goes. Here we go, right? So logarithmic equation. All right. Watch this. Let me get numbers up. let's do base 2. So log base 2 of, let's say, 3x minus 1. Okay. And then let's do plus. Let's actually do minus. We'll do this. So plus. So we have this. Let's do plus 2, and that's equal to logarithm base 2 of, let me show you this. So we have, let's do plus 10. So let's say we have, not plus 10, so plus 11. So let's say we have that. How do you deal with something like that? That's where you're looking, right? So a bunch of logarithms, what kind of equation is that, right? And so what happens here is we have to figure out numbers or number that makes this happen, right? How would you do that? Let me show you. It's a tough one. So watch this. So we have to do properties of logarithms. So let's bring together logarithms. Let's bring it together to one side. I'll give you a tough one right away. So let's do this. Let's just kind of log 2 of 3x minus 1. You see that? Oh, this is a tough one right away. Okay, I should have known a little lighter. I should have given you 1/2 example. Anyway, so we have this. Let's bring what is a minus that log? But the logs, I'm going to put them on one side, so you can kind of do something like this with them. Make it one log. Okay. So minus, what would you do? Minus what? Log base 2 of what number? What is that? 7x plus 11. Okay. So far, so good. All right. Now, watch this. Equals 2. Let's get the number out of the way. Subtract 2 from both sides. What is it, everyone? Let's try this. This is the top. There's nothing else to get this. Try to get this one. If you understand this, you basically understand everything in this class. So forth. This is for this sort of logarithm. This is the top one. So what is this? Subtract 2. You get what? If you just minus a 2, negative 2, right? Okay. Now, do you remember how we do what when we subtract logs? We divide, right? So what happens? What would you write? Log 2. Now bear with me. We're going to basically finish up after this one. So log 2 what? 3x minus 1 on the top and what? 7x plus 11 at the bottom, no? And that's what it tells you to do. Remember, if you subtract, you have to divide the logs like that. No? So weird as it is. What is that equal to? Negative 2, right? Okay, when you see that, make sure you don't have this equal to 0 right away, okay? You see that right there? You can't divide by 0, so make sure. But anyway, anything here, this has to be bigger than 0. Always remember, logarithm of anything, I forgot to tell you this part right here. This number, a and b, are always greater than 0. Well, it doesn't just have to be. If they're not greater than 0, stop right there. That number doesn't work. Error. Okay? A and b are greater than 0. Remember that. And c can be a negative. A and b are greater than 0. Not even 0, but greater. So make sure nothing here is. This is 2. That's not great. That's greater than 0. But this is all. These numbers better be greater than 0. We have to check later to see. Make sure. But look, what do you do here? Use the definition right over there. Let's write it. I don't like log. I don't want to see log all over the place. What would you do? 2 to the what power? Negative 2, right? Y'all see that? Everyone see that? So 2 to the negative 2 power is equal to what? This 3x, what is it? 3x minus 1 over what? 7x plus 11? Okay. Then what do? That's 1/4, isn't it? 1/4 anyone? 1 over 2 squared, isn't it? 1/4. Then what do? You want to cross multiply these? Make it easier, cross multiply. Well, okay, so what happens? 3x minus 1 times 4, what is that? Cross multiply. What's 4 times 3x minus 1? 12x minus 4 equals, what's 1 times 7x plus 11? 7x plus 11. Okay. What else? You get 5x is equal to what? What's 4 plus 11? 15? If 5x is equal to 15, what is x? 3, right? We have our answer. And let me show you the checking. Let's say you were to check. Let me check because I don't believe this. Check it. Check x equals 3. That it see it works, right? So what happens? What's 3 times 3 minus 1? Anybody know? What's 3 times 3? 9? What's 9 minus 1? So we have log 2, 8. This is the left side, right? Left. And this is going to be the right side here. So on the left side, log 2, 8 plus a 2. What's log 2, 8? 2 to the what power is 8? 2 to the what power is 8? 3, right? 2 cubed is 8. So it's 3 plus 2. What's 3 plus the 2? You have 5 on the left side. This is 3 plus 2 is 5. Plug in 3 here. What's 3 times 7? So what's 21 plus 11? 32. Okay, log 2, 32. 2 to the what power is 32? 32, everyone, is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. It's 2 to the 5th. So 2 to the what is 2 to the 5th? Such a trick question, right? Like a logic question. 2 to the what power is 2 to the 5th power? 2 to the what? 5. Make sense? Get it? 2 to the 5 power is 32. So this is 5. Are they equal, the sides? Left and right are equal. They're left 5. Make sense? We solve the equation. That's how you do one of these. Is 5, is it okay here? Yeah, there's nothing negative. There was nothing weird. It's okay. 3x equals 3 is the answer. Okay. Let me look at the time. And I'm going to say this. We're going to do one more. We have 11 minutes left. One more example, just like that one we did, log equation. But a more realistic one. And I'll show you a little touch on it that's a little different. So look at this log equation. And I'm going to basically do this right here. And I'll leave the properties, I'll leave that equation. Let's erase the property, the decomposition of logarithms. Okay? Just right here, this part of the board will work here. Okay? I'll give you one more logarithmic equation. Okay? So here goes. Example equation A. And let me show you an equation B example. Right? Actually, you know what? Example. Here's example A. Example 1. Okay? Example 2. This is specifically for equations. Obviously, we've done other examples. Okay? Here we go. Watch this. So, let's say we have something like this. Logarithm. Let's do 3. Okay. And let's do something like this. Let's say 2x. And let me do this even. Let's do 13 minus 2x equals. So we have this. Is equal to. Let's do 4 minus. log 3. All right, so we kind of did a little problem here. So we have, you know what, I'll do something over here. Let's do 3 minus log 3, and let me do this. I just keep it like 2x minus 1. So let's try that one. And what happens is you will get a number, maybe 2, and then you're like, how do you what do you do with that? And you got to check, make sure both of them work, right? So I think it may get more than one number. That's why I'm trying to show you this one. So this is a little different. This is like one of the toughest problems you'll ever do in a college algebra setting. Okay, a college algebra class, I use these problems sometimes. And actually, sometimes people ask you, you know what, like professor may ask you, find the sum of the solutions. Guess what? If one of, let's say you got answers like 5 and 2, what's the sum of the solutions? 7, right? But what if 5 and 2, maybe 2 doesn't work? What's the sum then? Just the 5. It's a very tricky question, right? So sometimes one of them doesn't work. But make sure, remember, this has to be bigger than 0, and this has to be bigger than 0. You remember that? Otherwise, we're going to be fine. Right? So let's check it out. Let's bring the logs together. What happens? Log, what? 3 of 13 minus 2x. Okay. Promise you guys, this is the last problem we're done. Get the answer? Check it. We're good. Call it class. So we do this. Add the log. What happens? Bring the log. Add a plus, right? What log? What? 3 of 2x minus 1. Is that okay? Okay. So yeah, bear with me here. Last problem, right? Let's try our best. Everyone try to participate. Equals what? 3? Okay. What do you do with these logs? Anyone remember? If we add logs, we what? Multiply, right? Like this. Say xy, xy, right? So log 3, what do you multiply? This quantity, what is that? 13 minus 2x times what? 2x minus 1, yeah. Now, we know FOIL method, everyone, right? We're about to do that. First, outer, inner, last, and we'll get, that multiply. What is this equal to 3, right? All right, let's first, and by the way, remember what this is? Anybody remember definition stuff? 3 to the 3 power is equal to that stuff there. You remember definition of log? How it works. Log A, B equals C. A to the C is B. This to that is this. Cool, right? So let's do this. What's 3? So it's 3 to the third is equal to what? 13 minus 2x is 2x minus 1. Y'all see that? That's the definition. Then what's 3 to the third? 3 times 3 is what? 10 times another 3? What is 3 times 3 times 3? Anyone? Anyone? 27, right? So 27 is equal to, let's do first outer and last. What's 13 times 2x? First terms. 26 what? X? What about outer terms? 13 times the negative 1. Negative 13. What about inner terms? Negative 2x and 2x. Minus 4 what? X squared, yeah. And then what about last terms? Negative 1, negative 2x. Positive, yeah? 2x. Right? What is that? Let's put together log terms. We're almost done there. What is it? Negative 4x squared, right? Then what? Almost done, everyone. Last problem. What is 26x plus 2x? 28x. And what about the minus 13? That's it? Minus 13? Anybody see how we're getting a what kind of equation? From logarithmic equation, we got a what? A quadratic. Cool, right? Just made it easier. We've done this before. So let's add 4x squared to both sides. What is it? 4x squared. Let's actually go here on the top, right? So you see this here? Let's bring it over here. Quadratic equation. 4x squared, right? Then what do? Minus, that's a 28. 28x. Everyone see minus 28x? Let's see if we got it right. And then what? What's 27 and add a 13? 27 plus 13 is? Anyone? 40, right? 40? Yeah. So plus 40 equals 0, right? That's cool. We can actually divide everything by what to just make it easier? You mind? 4. So what is it? X squared is equal, minus what, 7x, you see that? Plus the 10 is equal to 0. Is that okay? And then what do you do? Anybody know how to do that one? What do you do with this, anybody? X minus, how do you get a 10 and 7 in the middle? Minus, minus? Let's do factoring. X minus what? 5? Or what is it, 2? And x minus 5? Is that what it is? Did I do it correctly? But I messed up somewhere. Oh, positive. Oops. 1 second. Where did we mess up? I feel like we messed up somewhere. Let's see, anybody? Did we make a mistake anymore? Let's see. Oh, we're doing which one? This one, right? Okay. So yeah, I think it looks good, right? And so what is x equal to? 2 or x equals 5, right? Let's check. Let's check. You ready? I'm almost done. Let's see what happens. Is it really working? So let's check. Check this one. Check. X equals 2. Okay, let's do left side and right side here. Okay, left side. Ready? Put x equals 2 in. What happens? What's 13 minus 2 times a 2? What's 13 minus 4? 9, right? 13 minus 4, 9. So we're almost done. Log 3, 9, right? What is that? 3 to the what power is equal to 9? 3 to the what is 9? 3 squared is 9, right? This is 2. Cool, we have a 2 there on the left side. On the right side, let's see what happens. You know what, let me just do that here. We're going to do left side and the right side below. So log 3, we get a 9, that's equal to 2. So left side is 2. What about right side? We have to do a whole bunch of stuff. We have to do 3 minus log that, right? So let's do this. 3 minus log 3 of, what is 2 times 2 minus 1? What's 4 minus 1? 3. Okay, now let me ask you this. What's 3 to the what power is 3? Make it easy. 3 to the what power is 3? Just 1. So it's 3 minus, oh, that's just a 1. What's that? 2. They're equal. 2 is equal to 2, right? 3 minus 1. Okay, do y'all think 5 will work? Let's check. So the last thing we're checking, we're calling. So let's see. Check. X equals 5. Like, I don't, this seems like, does it really have 2 answers that both work? Let's see. The left side. Yeah, what is that? Yeah, so log 3 of, you have, put a 5 in here. 13 minus 10 is what, 3? Log 3, 3, what's that? We already know now. 3 to the what power is 3. What is 3 to the what power is 3, everyone? 1, right? 3 to the 1 is 3. So that's 1. That's the left side. What about this this here? The right side, what is it? We would do 3 minus what? Log 3 of what? What's 2 times 5 minus 1? 9. 3 to the what power is 9? 3 squared is 9, right? So we're doing 3 minus 2, which is what? 1. 1 is equal to 1. That's how you do logarithms. That's the toughest examples I can give you today. Right, everyone, thanks for being here. I'll end the recording, and I'll try to upload it in our notes. Okay, and yeah, tell people that aren't here that they should watch the recording and take the notes over that. All that. Right, have a good day.